This is Annie Powell, and today I will be talking about Physics 2212 Lab 3 circuits for Georgia Tech. So for the introduction, the purpose of this lab is using the principles of energy conservation and current conservation in order to predict the behavior of circuits containing resistors in series and parallel, using multimeters to measure the actual values of conventional current and potential differences in the circuits, and examining the behavior of ohmic resistors and capacitors. And then the systems and surroundings. So for surroundings, it's just, the system is the circuit, and the surroundings is everything around the circuit. Okay, so then our fundamental principles, Ohm's law, and then the node law, Kirchhoff's law, which is that current in equals current out. And then the loop rule, which is also one of Kirchhoff's law, and that's that the sum of all electric potentials in a loop is zero. And then the results, just like a preview, using Ohm's law and finding the potential difference in current in a circuit, we will find the following as resistance measurements, and so you can look here and see what those are, but we'll talk about that later. And then the setup, this is just kind of a picture of our original setup. Predicting the loop, so based on the loop rule, we have these calculations, so we're using Ohm's law and the loop rule and the fact that it's delta V is going to be 0, and so with that we can kind of just solve for I2, and I2 equals I1 based on the loop law, so that's going to be 3 over 147. And then our next steps in the lab, so we have a 100 ohm and 47 ohm resistor, and then we have our ammeter readings with those, and in reverse they're just going to be the same thing but negative. So the next step is going to be connecting an ammeter to a voltmeter, and when we do this, the voltmeter and ammeter readings are both 0 because voltmeters have high resistance, which is because the current goes to 0, so the ammeter starts at 0. And then step 4, measuring potential differences across circuit elements. And so then we have these listed here for the different resistors and then the entire battery, and then the value of the current throughout the circuit is 20 milliamps. So, and then we have this summing the potential differences. So we got 0.02 as our potential difference. Theoretically, it should be 0 because of Kirchhoff's laws, based on the fact that delta V should be 0. But there's some error due to human measurement, and we'll talk about that later. Okay, so then our final results based on all of that is that the potential difference and current measurements lead out to these resistance measurements. So we have a different one for the 47 ohm and 100 ohm resistor, and then the wires and the ammeters are still 0. And so we're using Ohm's law there. Okay, and then error. So error is nearby charge, incorrect mechanism, organization. So when we were putting the circuit together, if we did something incorrect, incorrect calculation, things like that. And then initial conditions and assumptions, just the resistance of the battery, the function of the clips and mechanisms. All mechanisms are working properly. The battery has accurate charge, resistors are accurate, things of that nature. And then discussion, this is sort of just kind of in steps 8, 9, and 10. But when we attach the voltmeter, why does the ammeter reading change? It's because amperes, or why doesn't the ammeter change? Amperes don't change due to resistance. And then for step 9, connect the voltmeter across a 100 meter resistor again and note the ammeter reading, 200 milliamps. And now when we replace the voltmeter with an ammeter in parallel, the current remains constant at 0.2 milliamps. Okay, and then final conclusions. Based on Ohm's law, the resistance values in the experiment are as follows. For the 47 ohm resistor, 40 ohms, and then for the 100 ohm resistor, it's going to be 90 ohms. For the wires, it's going to be 10 ohms, and the ammeter is 0. So this also goes into the fact that we can use the loop law and Kirchhoff's laws to get such conclusions based on the current and the potential differences. Thank you for listening.